Hello everyone, this is Kalpana here. In this video we're going to see few problems using direct integration. In order to get some idea, we'll just solve these 5 problems, okay, from partial differential equations. So let's get going. Problem, let's see the first one. We are going to use direct integration method, or sometimes you may call solution of partial differential equation in simple cases, whatever. Okay, so first problem, we are asked to solve dou z by dou y equal to sin x, right, which is a partial differential equation. Dou is nothing but partial, right? Partial. This is a symbol partial, or we call it as dou. Okay, whatever. So whenever we use partial differential equation, if we find derivative with respect to y, we'll treat x as constant. If we find some equation, or if we get any relation, if we solve that relation, if we just find the partial derivative of some relation with respect to x, then we'll treat y as constant. The other variables are treated as constant, right? We all know that. And we all know that z is a function of 2 variables also. So let's see how we are going to do this. So here we are going to partially integrate, or integrate partially with respect to, here we have y, right, with respect to y. So we all know that while integrating we'll get some integral constant or constant of integration, right? Constant of integration. While considering ODE, we'll just constant of integration. Okay, we'll just write some a, b, c, whatever. We'll just write some constant of integration, right? We use c, right? Regularly we use c. Let it be c. But in PDE, we'll get constant of integration, which is a function of another variable. Okay, instead of writing blindly c, we'll write constant of integration as function of another variable, which is a constant, which is treated as constant. Now we'll see this, right? Now partially integrate it with respect to y, you'll get z equal to sin x into y plus some integral constant. Here we are partially differentiating with respect to y, so we'll treat x as constant, right? X as constant. Here we'll treat x as constant. So here constant of integration will be some function of x, say f of x, g of x, or phi of x, or h of x. You can take any of these things. Okay, I'll take f of x. Now here we got y. Why we got y? Because we are treating x as constant. See, you can write this as, right, or we can write this as, right, in ordinary differential equation. If you want, you can consider ordinary differential equation just for the sake of understanding. Okay, if we have some cos y, let it be. Okay, then how you'll find constant of integration? If you have some, let it be sin x, nothing to worry, let's write sin x. Okay, then you'll get, what you'll get, y equal to integral sin x minus cos x plus some constant c, right? Likewise here we'll partially integrate, because we are having partial sign, right? We'll partially integrate, then what we'll get is z equal to integral sin x. Yeah, you have to treat it as constant, right? Sin x integral dou y plus, let it be. Okay, in the next step we can solve. We'll get z equal to sin x into integral dou y, which is y, plus you have to write some integral constant, right, which is a function of x, f of x, where f of x is an arbitrary function here. Okay, we'll say we call it as arbitrary function. Therefore this you can do, but always we'll do a mind calculation. Okay, we just don't do this because in maximum textbooks they have done like this. Okay, this is a where you can see this in rare textbooks. Okay, in rarely we can see this. Okay, but most of the books they'll just follow this. Okay, I don't know which book you are following, so just go like this. Okay, you can do mind calculation, integrating partially with respect to x, since you're having y in the denominator, right, which is a dependent which is independent variable y. So we'll treat x as constant. While treating x as constant, and also we are doing partial integration. So instead of writing a constant of integration, we'll write f of x. Okay, we are partially integrating with respect to x, so we have to strike this. I mean, your mind will just addict to it. You have to do. By practicing, you'll get to know. Okay, so this is how you'll get. So you'll have y into sine x plus f of x, where f of x is an arbitrary function. Okay, now let's see the second problem. Slowly you'll get to understand. Okay, don't worry, don't be in rush. Now the second one, dou square z by dou x square equal to xy. We can write this dou square z by dou x square as dou square z by, right, dou by dou x of dou z by dou x. Now partially integrating, first you are having dou by dou x, right? So we'll partially integrate with respect to x, or integrate partially better. Integrating partially with respect to x, this gives us, so whenever you see integrating partially with respect to x, you have to remember that you're going to get an arbitrary constant, and it should be in function of something, right? Since we are integrating partially with respect to x, so we'll treat y as constant, so that here we'll get integral constant which should be a function of y, right? Let it be f of y or g of y or whatever. So here we are going to take f of y as a constant of integration in this step. Okay, so we'll get dou z by dou x equal to, here we are integrating partially with respect to x, so we'll treat this y as constant, y into integral x is x square by 2 plus integral constant f of y. Easy, right? This will disappear since we are integrating, so this dou by dou x will disappear. You'll get dou z by dou x equal to constant y into, here we have x. We need to find integration of x, plus we need to write a constant of integration, which is f of y. Why we got f of y? Because we are partially integrating with respect to x. So y is treated as constant, and we'll have a constant which is in terms of function of that variable, which is treated as constant. Okay, right. So let's write it as dou z by dou x equal to x square into y, or yx square, whatever you can just write, or leave it like this. Okay, better let's leave it like this. Okay, for convenience, let's see what happens in the next step. But now here we are having x as a dependent variable. We have dou z by dou x. So what we can do now? We can integrate partially with respect to x again. So while integrating partially with respect to x, what we have to remember? We'll get a constant of integration, since here we are partially integrating with respect to x, so y will be treated as constant, and you'll have a constant, some g of y. Already we have used f of y, so let's take g of y here. Okay, this becomes the derivative dou, that partial disappears and you'll get z equal to, right, z equal to, y is again treated as constant, this 2 is also treated as constant. Let's write this as y by 2 into integrating partially this x square, okay, or just integrate this x square with respect to x, you'll get x cubed by 3 plus, here you have integral f of y, right, since f of y is treated as constant, so you'll get this constant into, we know that whenever we see some constant, okay, suppose if we write the same thing as, okay, just assume if we write the same thing as dou z equal to y by 2 into x square plus f of y into dou x, if we take this dou x to RHS, you'll get dou z equal to y by 2 x square dou x plus f of y dou y, right? Now we are supposed to integrate, then we'll get z equal to y by 2 into integral x square, since y by 2 is constant, right? Integral x square dou x is x cubed by 3 plus, you'll get, this is treated as f constant into integral dou x will give x plus some integral constant, right? Here you can just write x directly, but some people may get confused, so I'm showing this, okay? So here we have constant and we are integrating, so you'll get into x, with respect to x you are doing, so you'll get into x plus the constant of integration g of y, right? So you got z equal to x cube y by 2 3 is 6 plus x into f of y plus g of y, or you can just write it as f of y into x, nothing is wrong in it, okay? You can write it as it is, f of y into x, where this is a solution to a problem where f of y and g of y are arbitrary functions, okay? Whenever you get stuck, just write this, okay? At the beginning itself, at the beginning, by practicing 2-3 problems, you'll get to know what you're going to get after this constant. I mean, while integrating after this constant, you'll get x if it's with respect to x, or you'll get to, okay, you can see in the next problem. Okay, fine. Now coming to the third one. Right, now coming to the third problem. Here we'll see one more case, okay? You'll learn one more thing here. Fine. We can write this as dou by dou z of, dou by dou x of dou z by dou y, right? Equal to as it is. Now, first term, here you have dou by dou x, right? So we have to think that it can, now we can find the partial derivative of this with respect to x, okay? As soon as you see this, just do partial integration, not derivative. Partial integration with respect to x, or integrating partially with respect to x, since it is partial, integrating partially with respect to x, so we'll treat y as constant, right? That is the next thing you have to keep in mind. Since we are partially integrating with respect to x, so we'll treat y as constant, and here we are going to get an integral constant, and that will be some function of y. Okay, so here we'll get an integral constant or constant of integration, which is a function of y. It can be f of y or g of y or h of y or phi of y, whatever. Okay, fine. Now let's see. While doing integration, this dou by dou x disappears and you'll get dou z by dou y equal to And what you are going to treat is constant. Here y square is treated as constant, right? Let it be. And integral x square is x cubed by 3 plus this constant into, you'll have 1x, right? We have seen this in the earlier problem. So you can write the same thing as this 2 disappears and you'll get y square is constant, integral dou x will be x plus some integral constant. This is what we are going to write. You should not do all this every time. Whenever you see constant, put x, but plus some constant of integration f of y, right? Again, you have dou z by dou y, right? Let's integrate partially with respect to y now. Since we are integrating partially with respect to y, so we'll treat x as constant, and here we are going to get a integral constant, right? I mean constant of integration. Whenever we do integration, we'll get a constant of integration, and here it will be a function of x, some function of x. Already we have used f of y, so I'll take g of x. Okay, so this gives us z equal to, with respect to y, right? So this is treated as constant. You have constant into y plus constant into integral y square is y cube by 3 plus f of y. It is an f of y, right? You have to write this as integral f of y into dy. Since f of y, which is in terms of y, so you can write, instead of writing integral f of y dou y, you can write integral f of y dy, because here we have only one variable. There is no other variable, other independent variable. Like in ordinary, just compare with ordinary and partial differential equation, compare these two, then you'll get to know. Okay, you can just write to this f of y as integral f of y dy. Okay, because here we are having only one variable and we can treat it as ordinary differential equation or something ordinary d, right? This term as, and you can write it as integral f of y dy. Okay, fine. Plus, for this whole integration we have done, we'll get an integral constant, right? Let it be g of x. Okay, now assume integral f of y dy equal to some capital F of y, say. Then you'll get z equal to x cube y by 3 plus xy cube by 3 plus, we can write this as, because we don't know the exact value of integral f of y dy, right? We can't, it will look odd to show in the final answer. So what we'll do is, we'll just do some manipulation. We'll just write this as f of y so that it looks good. Say, not exactly. We'll just write it as f of y. F of y is nothing but integral f of y dy, where f of y and g of x are arbitrary constants here. Actually, we'll write like this, okay? This is a way. Sometimes we can't ask questions why. We'll just follow. That's the thing we have did here. Right now, this is a solution of the third problem. So what you have learned here, that you can write f of y while integrating partially with respect to y as integral f of y dy. Okay, don't forget. Fine. Now coming to the next problem, fourth one. So this is the most important problem. Not important. What you can say? You can say, you can see this in many question papers or in many textbooks. Okay, you may get confused sometimes, but it's not really as it looks, but it's definitely easy one. Dou z by dou x. I'll take the first equation. Solve the system of equations dou z by dou x equal to 4x minus 2y, dou z by dou y equal to minus 2x plus 6y, right? So I'm taking the first equation, I'll write it as equation number 1. Okay, so now we're having dou z by dou x, right? So we can integrate partially with respect to x, right? If we integrate partially with respect to x, we'll treat y as constant and we'll get a constant of integration which is in terms of y, right? A function of y, say f of y. So we'll get constant of integration f of y here, right? So let's partially integrate or integrate partially, whatever. Integrating partially with respect to x, so we'll treat, let's write treating y as constant. Nothing is wrong in it. Treating y as constant, right? Then this becomes z equal to 4 into integral x is x square by 2 minus constant into, you'll have x, right? I showed you how you got x. If you want, we can do once again. There's nothing wrong in it. You can write the same equation like this, right? Now apply integration. We'll get z equal to 4x square by 2 minus 2y into integral dou x is s. So this is what you have, x here, plus constant of integration. Already we have discussed, right? We are going to write f of x. So I did my mind calculation here and I wrote f of x. Since we are integrating partially with respect to x, so we'll treat y as constant. So the constant of integration will be in f of y. Good. Okay. Now we got z equal to 2x square minus 2xy plus f of y. Consider as equation number 2. Also here we have another equation which is dou z by dou y equal to minus 2x plus 6y, right? Let's see what we are going to get by partially differentiating it with respect to y. Okay, we'll see. Partially differentiating to, with respect to, we need y, right? With respect to y, I mean we need dou z by dou y equation, right? So we are partially differentiating with respect to y, we'll treat x as constant. Okay, remember here we'll treat x as constant, and this becomes dou z by dou y equal to partial derivative of 2x square with respect to y is 0 minus, here 2x is treated as constant, right? 2x into partial derivative of y with respect to y is 1 plus partial derivative of f of y with respect to y is f dash of y. What else you get? You'll get only f dash of y. Fine. So from this you got dou z by dou y equal to minus 2x plus f dash of y. Consider as equation number 3. But we have dou z by dou y equal to minus 2x plus 6y. You have two answers, right, for dou z by dou y. But we have dou z by dou y equal to minus 2x plus 6y. So you can equate these two, right? So equate these two, consider as equation number 4. Now from 3 and 4 we get, equate these two, you'll get minus 2x plus f dash of y equal to minus 2x plus 6y, which gives us, this minus 2 gets cancelled and you'll get f dash of y equal to 6y. See, everything is in terms of y. So here we can integrate it. It's just an ordinary integration, not the partial one, because we have everything in terms of y. So we'll get normal integration, and you'll get a constant of integration, which is just a constant. Okay, so this gives us what we are going to do, integrating with respect to y, because we have everything in terms of y, we can just do with respect to y itself, right? Then you'll get f dash of y becomes f of y equal to 6 into integral y is y square by 2 plus some constant, integral constant c. You'll get f of y equal to 3y square plus c, right? Now we got the value of f of y. Can we substitute this f of y in any of these equations? Can you see f of y in any of these equations? Yes, you have here, right? So now let's substitute this f of y in equation 2. Substitute f of y value in equation 2. Okay, then what you'll get, z equal to 2x square minus 2xy plus f of y. The value of f of y is 3y square plus c. So this is a required solution to this problem. Okay, which is a required solution, right? Now coming to the fifth one. Here comes the problem, which is a bit difficult. I mean, if you are not really good at derivatives or integrations, you may feel, but it's not actually difficult, it's easier given. So solve, the question is solve dou square u by dou x dou y equal to e power minus x cos y, given that u equal to 0 when y equal to 0 and dou u by dou y equal to 0 when x equal to 0, right? Now let's see the question, the equation. Dou square u by dou x dou y equal to e power minus x cos y. Okay, right. Now consider as equation number 1, which is the given equation. We can write this as dou by dou x of dou u by dou y equal to e power minus x cos y, right? Here the first thing you notice is we are having dou by dou x, so we can partially integrate it with respect to y, treating x as constant, and here you'll have constant of integration. You'll get constant of integration in terms of y, because y is treated as constant here, right? Because we are integrating with respect to x. Integrating partially with respect to x, treat y as constant. It's not necessary to write treat y as constant, okay? But this is the beginning. You're just learning now. You're keeping a little steps towards the problem. So let's write it, okay? And here we are going to get a constant of integration after integrating the equation. So the constant of integration will be in terms of y, right? Let it be f of y. Okay, we have decided f of y as a constant of integration we are going to write here. Right, now this gives us, this derivative vanishes by integrating partially this equation, right? So you'll get dou u by dou y equal to, here cos y is treated as constant. Now integral e power minus x is e power minus x by minus 1, which gives us minus e power minus x, right? Good. Plus integral constant, we have already decided, no? We'll just write the same thing, right? Very good. Now I'll write the same thing as, okay? Good. Now consider as some equation number 2 for our convenience, okay? Now get the problem. We have dou u by dou y, given that dou u by dou y equal to 0 when x equal to 0. Let's apply this condition here. Let's see what happens if we apply, okay? Let's go for trial and error method. There's nothing wrong in it. We are given, or we have dou u by dou y equal to 0 when x equal to 0. Simply substitute dou u by dou y equal to 0 and x equal to 0 and see what you are going to get. This becomes 0 equal to minus e power minus 0 or e power 0 simply into cos y plus f of y, which gives us 0 equal to e power 0 cos y minus cos y since e power 0 equal to 1, right? You can write e power 0 equal to 0. So you'll get minus cos y plus f of y. Now bring this cos y to LHS, you'll get cos y equal to f of y or f of y equal to cos y. So we got the value of an unknown, f of y equal to cos y. You can substitute here, right? By applying the condition, we got the value of f of y. Now, what we are going to do is, substitute this f of y value in equation 2. Then 2 becomes dou u by dou y equal to minus e power minus x cos y plus f of y, which is cos y. Here we are having dou u by dou y, so we can integrate it partially with respect to y, treating x as constant, and we are going to get constant of integration which will be in terms of x. It can be, here we have already used f, right? It can be g of x or h of x and whatever. In order to get rid of confusion, you can also write f of x. There is nothing wrong in it. But few people, what you'll do is you'll write f of x instead of f of y here, and you'll write f of y instead of f of x. Okay, you'll get some confusion. So instead of writing the same thing, just change it. Okay, and now let's integrate partially. With respect to y, treat x as constant. Right now this becomes u equal to, we have to integrate with respect to y, right? So minus e power minus x is treated as constant, and integral cos y is sin y plus integral cos y is sin y plus integral constant g of x. Okay, already we have used f of y, so let's use g of x here. Instead of f of x, we'll write g of x, or you can write h of x, y of x, whatever. So you got u equal to minus e power minus x sin y plus sin x plus g of x, right? Consider as equation number 3. Also, you have a condition that u equal to 0 and y equal to 0. Okay. Also we have u equal to 0 when y equal to 0, then this becomes, substitute your value of u and x, u and y, that's it. You'll get u equal to minus e power minus x sin 0 plus g of x. This gives us 0 equal to, sin 0 value is 0, right? Plus 0 plus g of x. 0 and anything is 0, plus 0 gives 0. So g of x equal to 0. This gives us g of x equal to 0. Or you can write it as better. Okay, let's write one more step. There is nothing wrong in it. Okay, 0 plus g of x, which gives us g of x equal to 0, right? Now substitute g of x value in equation 3. Substitute the value of g of x in 3. You'll get u equal to minus e power minus x sine y plus sine y plus 0, which gives us u equal to minus e power minus x sine y plus sine y, which is the required solution to this problem. So you can write the same equation as u equal to, just take sine y common, then you'll get u equal to sine y. Okay, you can write this as 1 minus e power minus x into sine y, which is the required solution. Okay, I'll give you one homework problem. Okay, I'll give two. Try to solve them. I'll give a different problem, which is another problem to be learned. Okay, I mean it's in another type. You can just think about it. Okay, I have explained these the 5 types. We have one more type, okay, that I'll solve in the coming videos. Okay, not now, because I want you people to think. Okay, so I'll give you some homework problems. Please try to solve that, and also try all the examples of your textbooks, not only from the textbook of one author. Try to refer 2-3 authors, okay, so that you'll get a good grip on the concept. Well, now I'm going to write the homework problems. Well, I gave 3 homework problems here. Okay, I think you can solve this. Okay, focus on, actually this we have already seen. You can try this also, but for this you have to think well. We have seen problems from partial differential equation using direct integration method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.